Hello friends, today we are going to discuss about the rules of differentiation. Rules of differentiation. The first rule is when the two functions are in summation, like they are in addition. So we can write this, we can split the function as f dash plus g dash. Or if you have a function in subtraction, f minus g whole prime, we can split this as f prime minus g prime. So based upon this, I'm going to take the example. Suppose we have a function which is equal to x5 plus x cube. So what is the derivative of this function? The 5 will drops down and 5 minus 1, 3 drops down and the power is being reduced by 1. So this is going to be 5 x4 plus 3 x raised to power 2. The second example is if you have a gx function which is equal to x7 plus ex minus sin x minus x plus 5. And we have to differentiate this. So this is going to be g dash x, which is equal to 7 x6 exponential function will remain as it is. The sine function derivative is cosec x, x derivative is 1, and the constant differentiation is 0. So when the different functions are in addition or subtraction, we can differentiate those functions individually. Now we are going to discuss about the rule number 2. Suppose we have any constant which is being multiplied with a function and the derivative. So we can take out the constant outside and write the function as f dash. So I'm going to take some examples. Suppose fx is equal to 3 sin x. So the derivative of the function is equal to the 3 will be outside and derivative of the function sin x, which is equal to 3 cos x. The second example is gx is equal to 7 ex. So the derivative of the function is equal to 7, the constant, and derivative of exponent is exponent function itself, which is 7 ex. The third example of this type is 5 x cube. So derivative of this one is 5 remain outside and x cube is the 3 drops down and the power is being reduced by 1. So the final answer is 15x square. Now I'm going to discuss very important rule. The name of the rule is product rule. As the name suggests, the product rule is applicable when the function are in multiplication. F dot g prime. So the product rule stated that differentiate the first function, write the second function as it is, plus f as it is, and differentiate the second function. So this can be also written as f dash g plus f g dash. So this is a product rule, very, very important. I'm going to take few examples of that so that you will get a better clarity. The first example is, suppose you have a function which is equal to x5 sin x. So how would you differentiate this? As you can see that the two function x raised to power 5 and sin x are in multiplication. So first we will do the differentiation of x5 and I will write the sin x as it is plus x5 and sin x differentiation, which is d by dx of sin x. So as we know that if you have any polynomial function, the power drop down and power is being reduced by 1 for sin x plus x5 and the differentiation of sin x is cos x. So this is how we apply the product rule. I'm going to take some more examples. The question is the function is equal to x ln x. So the derivative, the differentiation of the function is derivative of the first function, write the second function as it is, plus the first function as it is and differentiation of the second function. The derivative of x is 1 ln x plus x and the ln x derivative is 1 divided by x. So x is being cancelled out and the answer is ln x plus 1. I'm going to take some more example of the product rule so that you will get better clarity. Gx is equal to x square exponent of x. So if you differentiate this, differentiate the first function, second function as it is, plus x square and differentiation of the second function. It is going to be 2x ex plus x square ex. So this is about the product rule. Now, the next rule we are going to discuss is quotient rule. Quotient rule is applicable when the function are in division. F divided by g whole prime. So the quotient rule stated that differentiate the numerator, the denominator as it is, minus, write the numerator as it is, differentiate the denominator, divided by square of the denominator. So based upon this, I'm going to take an example. Fx is equal to x cube divided by sin x. So if you differentiate this function, x cube differentiation numerator, the denominator as it is, minus numerator as it is, differentiate the denominator divided by square of the denominator. So x cube differentiation is 3x square sin x minus x cube sin x differentiation is cos x divided by sin square x. So this is the first example of the quotient rule. Now I'm going to take the second example. Suppose we have gx is equal to 3x plus 5 divided by 4x plus 1. So how would you differentiate this? G prime x, which is equal to the derivative of the numerator and the denominator as it is, minus numerator as it is, derivative of the denominator, divided by square of the denominator. So if we differentiate 3x plus 5, 3x differentiation is 3 and 5 is a constant, so it is 0. 4x plus 1 minus 3x plus 5. 4x plus 1 derivative is 4x, differentiation is 4 and 1 is 0, divided by 4x plus 1 whole square. So if we just write down, it is going to be 3. 4x plus 1 minus 3x plus 5, 4, divided by 4x plus 1 whole 4.